All right, good morning, everyone. Thanks for coming today. This is the Automotive Futures 15th Annual Propulsion Strategies for the 21st Century Conference. Now, some people would say time flies really fast, but when I say this is our 15th conference, it really does feel like our 15th conference. It feels like we've been doing this for quite a while, and that we've been following originally the powertrain industry, now the propulsion industry, for 15 years. It's been fascinating, and there's no letting up, as you'll be able to tell today. And from our recent conference in April, we talked about EV challenges and opportunities, and today we're talking about the future of batteries. And we got some great speakers to talk about this, tell this story. This is really just the beginning of this story. We're going to be talking about batteries for a long time, but you got to start somewhere. And so today we're putting our stake in the ground for talking about what the future might look like in terms of batteries. So I'm going to start out by talking a little bit of our group. As I said, my name is Bruce Belzowski. I'm the managing director of the Automotive Futures Group. I'm retired from the University of Michigan Transportation Research Institute. We have our main funding comes from our affiliate program, our research, and our conferences. These are our list of our affiliates. We always like to thank them at the beginning, middle, and end of our conference, because without them, we could not do the conferences. So again, thanks to our affiliate members. We have research partners that cross IT organizations, OEMs, government NGOs, suppliers, and consulting companies. Some of our research projects that we're working on for 2023, the Propulsion Strategies for the 21st Century project. That survey will be going out in August. And for all of you who are online now, who have any knowledge about the propulsion industry, and we'd very much like to have you participate. If you're not already on our mailing list, please send me your email. One of the things that we've been working on probably since 2016 or so is EV evolutions. Particularly, we started out with China because they were the first ones out of the box in terms of doing new energy vehicles. So we've been studying them and tracking what's been going on in China, and now the US and the EU as well. New mobility is something that we've been looking at over a number of years. We've been doing 5 or 6 conferences on that. We've been we just recently finished the survey of electric vehicle challenges and opportunities, and that was for our conference in April. And of course, globalization at the crossroads, the nearshoring, reshoring. This is really an issue for suppliers in particular and manufacturers that we're going to be talking about again, similar to the EV propulsion strategy story, that the supply chain story is going to be something we're going to be following for quite a long time. It's something that we spent a lot of time looking at, in particular with Roland Berger back in the late 90s, early 2000s, with the beginnings of the system integrator role for the supply base. And we'll be going back to looking at that now, just because of all the changes that are going on in the supply chain. And one of our speakers today from Roland Berger is going to be talking about the supply chain risk that we're seeing in the automotive industry, and will probably be going on for quite a while because of the introduction of EVs. Our staff is made up of researchers. Kara Alkire will be presenting today. Sherry Netler is just joining us. We have student researchers. Yonchi Wu is here today with us, but most of our other students are interning this summer or looking for jobs. One of the things we like to emphasize is our LinkedIn page. It's really our only marketing program that we use. We don't use Twitter or Facebook or anything like that, just because we feel LinkedIn is a much more professional program for us to use. We're posting 2 to 3 times a week about our conferences, sometimes taking pieces from our conferences and talking about those. Sometimes a recent article that we think is important, as well as any research that we've been doing, and we'll take pieces of that and show that on our LinkedIn page. So if you haven't connected with us, please reach out and connect with us and follow us on LinkedIn, and I think you'll find it a valuable source. Upcoming conferences, September 13th, we'll be doing a conference some way similar to what we're doing right now. We're going to, in terms of artificial intelligence in the vehicle and in the organization, in terms of the automotive industry, again, really right at the beginning of this. I don't think anybody knows how this is going to play out in the short term or the long term, and we're going to be starting talking about that in September. In November, we're going to be doing our 16th annual Inside China Automotive Conference. It was our first automotive conference back in 2008. So we've been continually following, and now, and during that time, China became the largest automotive market in the world. All right, conference logistics. We've got great speakers. Jianguan Xin is joining us remotely from LG Energy Solution in South Korea. Brandon Boyle and Isaac Chan from Roland Berger are going to be co-presenting telling their story about supply chain risk in the battery industry. And Kara Elkire, our senior research associate here at Automotive Futures, is going to be talking about her work in terms of the investments that are being done or performed in the North American market related to EVs. So we'll start off with Jianguan, then Isaac, then I'm going to be talking about some of the battery information that came out of our EV Challenges and Opportunities survey that we just finished this spring. And then we'll have Kara, and we'll adjourn and go to lunch. And for those of you online, you should attend. This is one of the things that because we're a hybrid conference, we have, we've got 30, 40 people that are registered to attend in person, but we got 60, 70 people that are online. So we encourage people to come and take advantage of the networking that we have available by attending in person. In post conference, all the attendees get a link to the presentations and the video on our website. The affiliates get a link to the presentations and also a document that's a review of the highlights of the conference. Okay, housekeeping. The agenda, the speaker bios, registration list, sponsorship opportunities, affiliate information, upcoming events are on our website. All of you should have received that information. For all of you who are online, that's available to you. One of the key parts of the conference, though, are the audience questions and the conference feedback. We've got, for the people who are online, underneath the video, there's a description of the conference, and then there's a link to a Google Sheet where you can enter questions. For those of you who are here in person, we have the yellow question cards. Please fill out those anytime, during the presentations or after. Kara and our other colleagues here will be walking around picking them up, and we'll be taking questions from the YouTube chat. Yangqi is going to be monitoring that and sending those questions to me. So one of the things that we try to have is a discussion with our speakers. So you'll see the speakers will be part of other people's speakers Q&As, so that we can have a little more discussion about any particular topic that the speakers are talking about. All right. Every year, probably since about 2014, we've been tracking what the EPA has been doing in terms of looking at how well the manufacturers are doing in terms of their fuel economy, meeting their fuel economy goals and regulations, as well as their CO2 emissions and regulations. And we've done some every year we do some analysis that compares what's been going on, and the EPA for 2022 means they're talking about the 2021 model year, and this is preliminary data. They will finalize that by the end of this year. So they're a little behind schedule in terms of the year that they're working on, but it gives you a sense of how the manufacturers are doing on these important topics. Now, this is not completely related to the battery story, but it's something that we feel like is important to understand where the manufacturers are in terms of their fuel economy and regulatory goals. So this is going to be something that I put together with Yongqi. And so for these comparisons, they don't take into account credits received from the government or purchase credits from other companies that are used to meet their company goals, but they do take into account the mix of the cars and light trucks for all the manufacturers, as well as the sales volumes for all those models. So when you look at real world fuel economy, this is for the 2022 model year. Again, these are the real world values represent EPA's best estimate for real world tailpipe emissions and fuel consumption. These are, as I said, preliminary estimates, show that about half of the manufacturers shown will improve fuel economy for 2022. Mostly the Asian manufacturers are leading the way in fuel economy, which is probably no surprise to anybody who's been studying the industry. But also based on the preliminary EPA estimates for 2022 model year, Mazda had the largest drop in real world fuel economy, while VW had the largest gain, and Hyundai leads the real world fuel economy, while Stellantis has the lowest real world fuel economy. Let's look at some graphs to kind of show how this is playing out. At the company level, you can see that here's the drop by Mazda and the increase by VW. So when you look at it, that 7 companies increased their fuel economy, 5 companies decreased their real world fuel economy. In terms of cars for those companies, 10 companies increased in the car category and 3 companies decreased. Here you see Ford and GM dramatic increases in their fuel economy from 2021, primarily because they've kind of switched away from cars into building crossovers and SUVs that are treated as light trucks. And for the light truck category, 8 companies increased and 5 companies decreased their real world fuel economy. And you can see that Honda decreased, but VW increased significantly for light trucks, most likely the popularity of the Atlas. From the emission standpoint, now the EPA emissions between 2021-22 show that Mazda had the largest increase in real world CO2 emissions, while VW had the largest decrease. And in terms of and EPA estimates show that Hyundai had the lowest real world CO2 emissions and Stellantis had the highest. And when you look at this at the company level, you see the VW drop in emissions and the Mazda increase in emissions. And when you look at all the companies, you see that 5 companies increased and 8 companies decreased their real world emissions. When you look at cars, you see the big drop by Stellantis and the big increase in VW. For light trucks, you see the big drop for Hyundai and the big drop for VW, which is exactly what the government would hope for. But when you look at it, there's a lot of companies that there's a number of companies that actually increased their emissions. The other area that we looked at was footprint. So footprint was one of those stories where during the Obama administration and the goals for 2025, they always expected that they would have Wait a minute. I want to see something for a second here. Okay. They always expected that the companies would start making smaller cars to be able to meet their fuel economy, which means the footprints would decrease. And what you'll see here is that the industry-wide, they projected show little or no change in 2022, with only 2 of the 13 manufacturers significantly reducing their footprint of their vehicles. Ford and Stellantis still have the largest total footprints, while Subaru has the smallest total footprint. From at the company level, here you see some increases in footprint from Kia and decreases from GM, but there's a lot of companies that are pretty much stayed the same. At the car level, you've got the Mazda decrease and the Nissan increase. These are very small but significant, but you see a lot of companies that are not doing many changes at all. And in light trucks, you see you see Honda increases and a Hyundai decrease in terms of their footprint. When you look at, as I said, we kind of been tracking this since 2014, and you would kind of expect that since 2014, that's quite a long time, even for the auto industry, where we know that there's a life cycle of a vehicle takes a long time for us to work its way through the system, and new vehicles don't come out dramatically different every year. So we expect over time some changes, and I'm sure the government was hoping that they would have better fuel economy and lower emissions over this period of time. But for most companies, you'll see that they did improve their real-world fuel economy. Kia increased their the most by 11%, while Mazda decreased theirs by 8%. And let's look at the company level. You can see the Kia, you see Toyota increasing their real-world fuel economy. Actually, 10 companies increased their real-world fuel economy, which is pretty good. But when you think about it in terms, when you look at the numbers and the differences between 2014 and 2022, these, I mean, in some ways they're dramatic, but in some ways they're not that dramatic. Yeah, I think the government would have been hoping and expecting that the companies would do better. Now, in terms of meeting their regulatory goals, they have credits that they have, and they also have credits that they can purchase, and they have lots of different ways that the government allowed them to using different air conditioning fluids, having biofuel vehicles. They have a variety of things that they were able to do. And obviously they took advantage of that. And this is so in some ways it's not surprising, but I'm sure the government would have hoped that they would have done better. In terms of for cars, every company except Stellantis improved their real-world fuel economy for cars, and for trucks, all the companies have improved their real-world fuel economy, which is except for Stellantis, which is a pretty good sign overall. How dramatic that is, that's another story, right? How much they've improved fuel economy. And this is for cars. You can see Kia has some dramatic increases, as well as General Motors and Ford and a number of the companies. Only 2 companies actually decreased their fuel economy, Stellantis, and it looks like, I think it's basically Stellantis. That actually decreased their real-world fuel economy. For trucks, you look at all the companies increased their fuel economy. This is where there's a lot of focus has been on the growth of SUVs and light trucks in the U.S. Probably, and I remember when the Obama administration were making their plans for 2025, they were assuming that there would be something like a 50-50 split, or maybe a 60-40 split of cars over light trucks by 2025. were they wrong, because even within the last few years, we've got 60 to 70% of vehicles of the share is light trucks. So they've really had to make some changes and adjustments in their estimates of what they thought the industry could do. And again, the industry would argue this is what consumers wanted, and they're purchasing these vehicles, which is why they're doing what they're doing, and why their numbers are the way they are. So in terms of emissions, now every company except GM and Mazda has improved their rear world emissions. We see that Kia had the biggest decrease in emissions, as well as VW. So all the companies have been doing pretty good, though two companies actually increased their emissions, General Motors and let's see, who is the other company? Looks like Mazda. Increased their CO2 emissions. From in terms of cars, most companies reduced their emissions, and for trucks, all the companies reduced their emissions for trucks. Here's the car story, where you see that two companies actually increased their emissions, but most of the companies have decreased. Again, since this is since 2014, one would hope that there would be these kinds of reductions. And one could argue that maybe the emissions reductions are probably even more important than the fuel economy reductions, though, or its fuel economy increases. But it has a lot to do with those two things being interrelated. All right, footprint. All companies increase their footprints in general. Again, not something that the government was expecting, led by Stellantis and Ford. In terms of cars, yeah, you look at you got Mercedes doing the biggest jump, and Mazda doing one of the smallest reduce in terms of reducing their footprint. See, for trucks, the 8 companies increased and 5 companies decreased their footprint. So it really shows you that the growth of light trucks has shown has also led to the growth of the vehicle footprints. One of the last things we want to look at was the credits. So when you look at the credits earned by the companies, half the companies generated a deficit for model year 2021. Stellantis lost the most credits, mostly due to light truck sales, while Tesla gained the most credits, and due because of, guess what, EVs. So you can see this, but General Motors is right behind Stellantis in terms of the decrease in or negative deficits in credits. For cars, Stellantis was decreased. Of course, Tesla is up. In terms of light trucks, you see a number of companies got positive credits for trucks, but GM led the way in terms of negative credits for trucks. When we compared the previous year, 2020 to 2021, you see some interesting comparisons, pretty much going in the same direction, except for Toyota increasing their credits overall, and Ford increasing their credits a little bit compared to what they had in 2020, and GM increasing their deficits. And for cars, of course, Tesla has actually gone up, probably because of their sales increases, and you see the other companies going down or up, depending on how they were doing in 2021. So again, this is for light trucks, and you see the Toyota kind of balancing it out from one year to the next in terms of their the credits that they're earning, and General Motors struggling a bit with their credits. So that's all I had to talk about for this part of the conference. I'll be back at the beginning after the break to talk about some of our results, battery results from our EV challenges and opportunities conference and survey. And now I want to turn it over to our Jangwon Shin from LG Energy Solutions. And Jangwon, do you want to share your slides? While you're doing that, Jangwon, I'll do a little introduction here. Jangwon is the Vice President of LG Energy Solutions Strategy and Business Development with responsibility for the Mobility and IT Battery Division. He has over 19 years of experience with LG in the areas of business development, corporate strategy, and supply chain management. He also spent 5 years with Samsung Electronics in the R&D function. He's considered a lithium-ion battery industry and battery material expert who brings us in-depth understanding of the battery industry to his company. Thank you for joining us, Jangwon.
So, hello.
Yeah, we can hear you. You're loud and clear.
Okay, thank you. Hello, my name is Jang Hwan, and I'm Vice President of Strategy in LG Energy Solution. First of all, congratulations on the 15th Advanced Powertrain Conference. This is the third presentation at the Advanced Powertrain Conference. This year, I really wanted to talk to many people while giving an on-site presentation in Ann Arbor. But due to my schedule, I had to say hello through the screen. Hope to see you in the next time. I have been active in the Automotive Future Research Group since 2015. The experience of working in Ann Arbor for a year at that time has helped me a lot in my career.
Jangwon,
yes.
Can you hold on a second? I think I forgot to stop my share and have you do your share. I wanted to make sure that you could see it on the YouTube video. I want to.
Okay.
Can you hold on one second? I want to make sure people can see your screen. Okay.
So, okay.
You're good. Go ahead.
Okay. So okay. So they're gonna see my. Okay, just hold on.
Oh, that's you. That's your screen. Okay.
Okay, you can see.
Yeah.
Right? Okay, okay. Go ahead. Okay, so I hope that my presentation will have some help to the research achievement of Automotive Future Group. What I will present today is the battery business strategy and the research development strategy of LG Energy Solution. Business strategy will focus on business portfolio, production portfolio, and product portfolio. As of research and development, I will tell you about product currently under development and product to be developed in the short term and in the long term. LG started battery business 30 years ago, and now 5 countries are producing or preparing to produce LG batteries. Last year, our company sales were almost 20 billion, and it will expect to triple in 3 years. The business area of LG Energy Solution are divided into 3 areas. First, it is the Automotive Battery Division. This is the division that rectangular size batteries for car as seen in the picture. Customers are mainly from existing automobile companies such as GM, Ford, Volkswagen, and Toyota, or something like this. And the Mobility Battery Division, also sell automobile batteries. The difference from the Automotive Battery Division is that the Mobility Division produces cylindrical batteries. Companies dedicated to electric vehicles such as Tesla, Lucid, Rivian are our main customers. Finally, the ESS division, LG sell products that improve the efficiency of the power grid or renewable energy. The content I will be presenting today is mainly related to the Mobility division because I'm in charge of the strategy of the Mobility division. This is the global network of LG Energy Solution. Because the history of the battery business is long, global battery experience is also very long. The current production scale is about 285 gigawatt hour per year, and the share of cylindrical battery is almost 25%. In 2 years, the production will scale up to 540 gigawatt hour per year. I will briefly tell you about the history of LG Energy Solution. Our parent company, LG Chem, was founded in 1947, which marked the beginning of the LG Group. In 1992, 45 years after LG Chem, the parent company of LG Group began researching lithium-ion batteries for the first time in Korea. 7 years later, in 1999, we began mass production of lithium-ion batteries for the first time in Korea. In 2020, mass production of cylindrical batteries for electric vehicles began. The advantage of LG cylindrical battery is that it has high energy density and excellent output on a cell basis, and while being able to respond to supply based on standardization. The standard size of the cylindrical battery is the biggest advantage. Major customers are electric vehicles such as Tesla, Lucid, Proterra, Nikola, or Arrival. There are also e-scooter, e-bike customers such as Honda, Gogoro, or Bosch. This is the cylindrical battery product roadmap. 1865 is a battery originally applied as a notebook battery. It is still used in the Tesla Model S. And 2170 is a 50% increase in capacity. It is the battery product used in most electric vehicles that currently use cylindrical battery, such as Tesla Model Y or Model X, Model Y and Model 3. The 46 size battery has now been developed and it is in the stage of mass production. The shape of an increase in the diameter and the height of the existing cylindrical battery, but the internal structure is completely innovative. This is the battery that Tesla announced at Battery Day. The number of cells written above is the number of cells required to configure one electric vehicle. Until now, it has been difficult to build a system for cylindrical battery due to their standardization-based supply responsiveness and low capacity despite price competitiveness. It is size the 46 that can overcome. This is the feature of LG 46 size battery. Excellent safety and the resistant performance by combining the low resistance TEMNIS technology, which is pouch battery technology with the strength of the existing cylindrical batteries. In addition, cost competitiveness is excellent based on standardization and commonization. This is also what Tesla announced at Battery Day. And this is the comparison of the performance of a 46 size cylindrical battery and 2170 size, which is the existing cylindrical battery. And most of the performance is achievable with existing battery level, but it is characterized by low resistance and excellent productivity. This means the production speed is 150% faster. So far, I have spoken about the business strategy of LG Energy Solution and the products currently under development. This page explains the characteristics of batteries that LG Energy Solution aim for in the short term. First of all, the needs for electric vehicles are largely composed of 4 parts: mileage, cost, fast charging, and durability or safety. In line with this, 4 key materials for battery are being developed, such as the driving distance is connected with the cathode, and cost is connected with anode, and the quick charging and durability is related with the separator, and the safety is related with electrolyte. Let me tell you about the fundamental competitiveness of LG Energy Solution batteries. First, it is the material technology. Among major battery companies, only LG Energy Solution is based on a chemical company. We are leveraging our strengths in material technology to improve product performance. Also, overseas business experience. LG Energy Solution has operated a battery factory here in Michigan for the past 10 years. It is also the first overseas companies to operate a battery factory in China. Finally, the process technology. Based on the experience of the pouch battery and cylindrical battery, pouch battery is almost used in the legacy OEM, and cylindrical battery is almost used in the startup electric vehicle company. And it is leading future process technology by combining the strengths of the two types of batteries. And from this slide, I will present about the next generation battery. Next generation battery means this battery will be produced in maybe almost year 2030. From a long-term perspective, LG Energy Solution is preparing all solid-state battery and lithium-sulfur battery as the next generation batteries. All-solid battery is the battery that replaces the existing flammable liquid with a solid electrolyte that transfers ions between the anode and cathode. Since solid electrolyte is used, there is no risk of fire, and there is no need for safety device or separator to prevent temperature change or external shock. So it can be used in various ways depending on the purpose of use, such as high capacity, miniaturization, and diversification of shape. Lithium-sulfur batteries are made from lightweight materials, such as sulfur carbon composite in the cathode and the lithium metal in the anode, giving them an energy density 1.5 times higher than conventional lithium-ion batteries. So, it's a solid-state battery is applied to e-mobility, such as wearable device, ship, aircraft, and robot. And the lithium-sulfur battery is because of its high energy density and lightweight, it can be applied to UAM and drone. It is the device that can employ next generation batteries such as all-solid battery and lithium-sulfur battery. As I just mentioned, that it can be used in EV or wearable device or mobility, and the lithium-sulfur battery can be like this drone and like this air flight or UAM. We are leading the future of battery technologies through continuous R&D. LG Energy Solution is ahead of the battery cell, module and pack, as well as simulation and digital transformation. Although we are very specialist in the battery and cell, and our company is based on the battery material and the battery cell, we expand our business to module and pack, and also simulation and digital transformation. LG Energy Solution is building the next generation battery portfolio optimized for market requirement based on proven technology and industry largest production capacity. Lithium-sulfur battery, next generation battery that have the advantage of lightweight and price competitiveness with life cycle and performance technology directed toward new aircraft market. And solid-state battery developing both polymer-based and sulfide-based batteries. Polymer-based solid battery with existing mass production process are targeted for commercialized by year 2026. Currently, the development of next generation battery is almost complete. However, along with the development of next generation batteries, the performance of lithium-ion battery is continuously improving. It is expected that the next generation battery that suppress the performance of lithium-ion battery will appear in year 2028. The remaining issue is battery cost, but I think it can be overcome based on excellent performance. But right now, the lithium-ion battery is continually improving its performance and continually decreasing its cost. So that's why, although we already completed the development of the next generation battery, but sorry, it takes more time to commercialize these two technologies. This is the last slide. The energy solution is trying to lead not only the first life battery, but also the second life battery ecosystem. So we are producing from raw material and the material and part and R&D and the production, battery cell and the module. And this cell is applied to the electric vehicle and IT and mobility and ESS. And this is the first life of battery. And from second life is we may repurpose and reuse the battery based on our technology, and we can evaluate the battery life. And if the battery life is over, and then the battery can be recycled, and then it can be used again as a material and a part. This is the last page I'm presenting. Okay, thank you.
Thank you very much, Jingwan. We're going to do a Q&A with you right now.
Okay.
We've got, of course, we got lots of questions for you. Just based on your presentation.
Okay.
Where will LG grow their footprint by 2025 to reach their 540 gigawatts goal?
You mean which area?
Yeah, which area of the world?
Okay. So 550. The most part is in North America. Okay, the North America is 45%, and Asia is the China and Indonesia is 35%, and the remaining 20% is in Europe.
Very good, thank you.
That answer your question?
Did you say you have some others?
We invested in North America, Europe, and Asia. Asia means it's China and Indonesia. North America means it's USA and Canada, and Europe means it's Poland and Germany. We have the R&D, and it's Turkey. We also planning to invest in manufacturing battery cell in Turkey.
Here's a question for you about the sodium ion battery.
Okay.
Based on your opinion and vision, will sodium ion batteries have significant market share for automotive applications in the next 5 to 10 years?
So you want my comment about the sodium ion battery?
Yes.
What?
No, the sodium ion battery. Yeah, I'm sorry, lithium. I guess I guess the question is about sodium ion. Have you guys worked on anything on the sodium ion battery?
Yeah. It's also we are trying to research the sodium ion battery, but the sodium ion battery is although the sodium is very cheap material, so it can be produced very cheap cost. But the limitation is the sodium ion battery. It has the heavier than lithium ion battery, so it's very limited application. Okay, so the sodium ion battery can be applied to ESS, but it's very limited to apply to mobility.
Very good. Thank you.
So some Chinese battery company, they are trying to produce the sodium-ion battery, but in Korea battery company, we research sodium-ion battery, but we are focused our next generation battery in solid state and lithium sulfur battery.
Ah, okay. Thank you. We've got a few questions about your relationships with your manufacturing partners. The first one was you have a strong relationship with General Motors with the Ultium battery, right?
Right.
How does the Ultium battery compare to some of the other battery technologies that you were talking about?
But the Ultium battery is look like this. Okay, it's a rectangular size battery.
Yeah.
And this battery is applied to the existing OEM, not startup, the legacy OEM, like the big automotive company, like they have the engine car, and also they also develop electric vehicle car. And this is the battery. This battery can be used in Tesla or Lucid or Rivian. It's a startup company. So almost all performance is almost similar, right? It's energy density and the charging, everything is similar. But the difference is how we can make the pack system based on this cell. Okay, so this cell can be configured in the stacking or some other size, but this cell can be configured in the just stand, right? It's a stand. So it's maybe the configuration of the pack is different, but this performance is almost the same. And also, but the safety of and the life cycle of the cylindrical battery is slightly better than the Ultium battery. So Ultium battery is based on the pouch technology. Okay, so this battery is the characteristics is almost the same in cylindrical battery, but the safety and also life cycle, the specification is a little bit different. But it's not a good or bad thing. We produce the two type of battery.
Very good. Thank you. Another kind of a relationship-ish question here. Do you foresee the manufacturers like Tesla insourcing battery cell production?
Tesla already manufacture battery in-house. And some other company in Europe and also some company in China, some automotive company, China, they also interested in producing battery inside, right? But it's difficult because the battery business is in need a lot of investment, right?
Yes.
But it's almost all vehicle company, they need to invest in electric vehicle. So they don't have enough money to invest the battery. So I think the automotive company like Tesla or GM or Ford, they try to get knowledge about the battery cell or battery through the try to producing in-house. But they will depend on the battery specialized manufacturer in the long term, in the long term as well as in the short term. That's my opinion.
Yeah, very good. Thank you. Yeah, it seems like that is and when the question asked about production, but of battery cells, but there's also the R&D into battery cells and development of battery cells that you were talking about that LG has put so much, and all the other battery companies are putting so much funding and support because that's your business, right? So to be able to take that over, it must be very different.
The chemical knowledge and the mechanical knowledge, right? The automotive companies, they are very good in mechanical knowledge, but it's chemical knowledge is based on very accumulation of the knowledge. So we are start our battery business for 30 years because of the chemical reaction is we need so many data. So based on our R&D data and the production data, and then we can make our battery safer and it's very good performance. So, but the battery itself is very important in the electric vehicle. That's why the most electric vehicle company are very interested in battery R&D and also battery manufacturing. But this battery domain knowledge or to produce battery, it takes a lot of time, a lot of resources, and a lot of investment.
Got a couple questions about recycling.
Okay.
Who is LG partnering with for recycling and second use?
So basically, LG is we are a very big company. So inside of the LG group, we have a partner. So it's LG Energy Solution. We producing battery cell, and also we have LG Chemical, our mother company. They are currently our recycle partner. And also we also have the outside partner in US and Europe, but I cannot specify the name of the battery, the recycle partner name, the company.
Okay. Let's see, I have a couple other recycling questions. Hold on a second.
Sorry.
I guess one of the questions has to do with the timing for having a fully recyclable cycle of batteries that can then be put into turned into new batteries. I mean, this is an issue that a number of people have been talking about. Has to do with do you have enough EVs on the road? And when those, how long will they be on the road? And then how long will they be so you have enough batteries to actually recycle and then reuse that material. And one of the things that we talk about sometimes is if you use batteries for second use, now they eventually will become recycled, but it keeps them from being recycled immediately and then getting into the stream again. How do you see that playing out in the future?
The recycle business is depend on the scrap or the used battery. That means if the used battery the amount of the used battery is very huge and the recycle business is very profitable. But right now, the used battery, the scale of the used battery is very small. That's why the recycle business is not that profitable. So it depends on how much used battery we can collect. And also the material from the recycled battery is very pure, and also its performance is almost similar. So, for example, if our material is from the mining, and also if our material is from the recycle, the performance is almost the same. Okay, so I think maybe 5 years, maybe year 2000, after maybe 2 or 3 years later, because the life of the electric vehicle is based maybe 8 to 10 years. So right now, the electric vehicle P rate in the world is almost 12 or 13, right? So we are maybe producing electric vehicle maybe 10 million or 12 million vehicle per year. So after 5 or 6 years later, we will have a lot of the used battery. So based on the lot of the used battery, we can recycle, and this recycled material can be very profitable at that time.
Very good. Thank you.
Okay.
I have a couple questions about, and you were talking about the life of the battery, but one of the issues has to do with And I think we talked about at the last time you spoke at our conference about being able to measure a used battery for its life. To measure the life of a battery over time. And you thought that, I think at the last conference, you were thinking that this is something that was coming close to be ready to be able to measure the life of the battery, especially for a used vehicle, right? If you're purchasing a used vehicle, you would want to know how much life does this battery have left. Where have you guys are on your research on that?
Okay, so actually the battery has very long life. So it's when we sell our battery, we guarantee it's maybe 1,000 cycle life, but the battery never die after 1,000 cycle life. And we analyze the remaining battery life based on our data. So we have the battery research data and the battery manufacturing data. And automotive company, they have the battery usage data. These three data is combined. And then based on this combined data, we can analyze the exact remaining life of the battery. And this technology is already already completed, almost completed in Korea. So we are some kind of, not in the business, but we are we try to test this technology in Korea, applied to rent car, like Hertz or some rent car company, because the rent car companies, their electric vehicle usage environment is very severe. So it's very important to how many life is remaining in the electric vehicle. So it's this technology is almost completed, and I think it will be very important technology in the world in the short term. So there's two things. So one thing is SOC. SOC is the remaining cycle life, and the other one is SOH, remaining the battery life of the remaining the health of the battery. The cycle life, the calculation is very simple, but the remaining useful life calculation is very difficult. So we need a lot of data. So we are partners with a lot of OEM in the world, and we try to increase the accuracy level of the to analyze the battery life.
Yeah, there's no simple process for seeing how much life is left in the battery, is there?
But it's not that difficult. It's not that difficult because we have the data because for example, if we expect some people's remaining life, we want to know the gene information and his living habit. So based on these two data, we can calculate the remaining life of the human. That's very simple. In the battery, we don't want a lot of data. We want some point, for example, the ampere or voltage or something like this, and the temperature. Maybe these three is the most important thing. And based on this data, we can estimate the remaining life.
Okay. Very good. Thank you. We're just about done with our Q&A here with you. One of the questions that we have had to do with range of the vehicle, and also will there be different types of batteries available for different types of drivers? So I think this may be the difference between the LFP versus the NMC type battery, and also in terms of and a kind of a follow-up to that is, can you imagine an EV having a longer range of vehicle than an ICE vehicle?
Yes, of course. First, it depends on the pack size and also it depends on its energy density, right? First, the average of the ICE vehicle driving range is maybe 500 kilometer or 600 kilometer, maybe. It's maybe 300 miles or 400 miles, right? For
Yeah.
for pure full gasoline at the bottom of. But and also the electric vehicle driving range is almost the same, right? So we think it's maybe the driving range may less than 500 kilometer is LFP is also applied to the vehicle. But if the vehicle, the driving range is more than 500 or 600 kilometer, and then the NCM battery is more proper than LFP battery because it's NCM battery. NCM means it's the material technology that can be applied to cathode, and this cathode is higher the energy density than LFP, maybe 20 or 30% more higher energy density. That means its driving range is longer than LFP battery.
Okay. Yeah, I was wondering if you could, if we can imagine a buyer saying, I would like to have a battery that I don't need a battery that is going to go 600 kilometers and actually be able to order for their new vehicle a battery that meets their needs. Can you see this as a potential option for buyers in the future?
Yeah, right. Maybe if you want to buy Tesla Model 3, you have option, the standard range and there's a performance range or the long range. Long range version is used by the LG battery, but the standard version is used by the LF battery. Okay, so the LF battery is a standard range is maybe its mileage is shorter than the long range version. So you can choose.
Yeah.
Although the price is a bit different.
Can you imagine the manufacturers offering that kind of that kind of?
They already in the although in the inside of the same vehicle they have option the short range version and the long range version, and the short range version is based on the LFP battery and the long range version is based on the NCM battery.
Ah, okay. Yeah, very good. All right, I think you have answered almost all of our questions. Thank you very much, Jang-Won.
Okay, thank you.
We very much appreciate you taking the time and giving us your insight about LG, but also your opinions about what you see happening in the future for batteries. We very much appreciate it. We will be in touch.
I remained my email. So if you have any question, just please let me know anytime. Okay, thank you.
All right, take care. All right, for our next set of speakers, we're going to have a repeat performance by Brandon Boyle from Rowan Berger. Now, Brandon said his colleague Isaac Chan is going to be doing most of the talking, I think, on his presentation. Isaac Chan is partner at Rowan Berger Consulting, working with industrial companies to solve complex strategic topics, including growth strategy, business model innovation, and digital disruption. With over 10 years of consulting experience, he's an expert on the ongoing transformation of transportation and mobility space. Isaac holds a BS in Industrial Engineering and Economics from Northwestern University and an MBA from the University of Chicago Booth School of Business. Welcome. We're going to start off with Isaac.
All right. Thank you, and it's a pleasure to be here. So today we're going to spend a little bit of time talking about the risks within the lithium-ion battery supply chain. As a brief introduction, Rowan Berger is a global management consulting firm. We do have a team that specializes on battery topics. We have a presence in North America, Our global team is present in North America, Europe, Japan, Korea, China, and India. We have worked with companies on battery topics throughout the automotive value chain. So that includes, this is just a subset of the companies that we work with. In particular, we basically help companies make big ticket decisions. We help executives parse through kind of what is the actual signal from the noise, and gain confidence in making the right decision, particularly when there's so much capital, so much strategic, let's say, capital to be won or lost. In this talk, we're going to cover these four main questions. So first, how is electrification driving the battery supply chain? Where are the risks in the battery supply chain? How are policies shaping these dynamics? And then how are companies managing these risks? It's obviously a lot to cover in about 20 minutes. So we're going to go a little quickly and feel free to ask questions to drill down into any topic. So everyone has their own forecast of electrification. General consensus is around that by 2030, various regions are going to be approaching or a little past 50% battery electric vehicles. Our forecast is not generally out of line with any of the other ones out there. Maybe we're a little on the conservative side as players go right now. But when we translate these types of volumes into actual battery demand, and we add up across other types of applications for batteries, we come to a total of about 5.1 terawatt hours. That's 5,100 gigawatt hours in 2030. About 75% of that is driven from light vehicle BEV demand. But there's other applications that register in there significantly, like energy storage systems, commercial vehicles. And if you notice, consumer electronics is only a very, very small portion, even though it was the majority of the market, about a decade ago. Now, in order to support the production of that many batteries, you need a lot of new materials. So we heard from some of the earlier talks about LFP and nickel-based cathodes and the anode technologies out there. This is a simplified version of the supply chain and the materials that go into it. And for those who aren't as well versed in the chemistry behind this, there's two main types of cathodes that are used in mobility applications today. So that's LFP and then nickel-based, or NMC, or there's also NCMA, and there's variations thereof. But it's basically a combination of nickel, cobalt, and manganese. Now, as inputs to those, you have nickel sulfate, cobalt sulfate, manganese sulfate, as well as lithium. On the LFP side, similar type of analogous setup, but it's mainly lithium, and then you have the manganese and phosphate. On the anode side, you're really dealing with graphite today with varying mixtures of silicon baked in. Next gen technologies focus on introducing lithium into the anode and getting higher shares of silicon within the anode. So that's to say, you have a lot of new materials that are making their way into the battery and into the vehicle. On the left here, we have a chart of what prices did in 2022 and 2023, as there began to become a lot of concerns about potential lithium shortages. So you can see here the level of price spike in lithium hydroxide and lithium carbonate, which are two of the forms of lithium that make their way into batteries often. And when you translate what a 2021 Q1 timeframe type of cost of a cell did going into 2022, best in class cost of a cell, and this is on a nickel-based battery cell. You can see it, just that increase in material prices over that time caused the battery cell cost to go up about 30%. Now, if you multiply that $107, or that delta of $25 times 100 kilowatt hours per vehicle, it's a pretty significant increase in your bill of material and in the price that a consumer would be facing, or on the OEM margin. So for a lot of these materials, we need to scale up what we're producing. And it's important to contextualize that against the amount of these materials that's coming out of the ground today for other uses in other industries. And so as you paint a picture of each of these raw materials, we can see there's some areas that are a little more at risk than others. There's some areas that have to grow a greater share in proportion to others. And there's also, of course, different geographic dispersions of these materials, and there's different levels of difficulty with developing new sources of resources for these. One of the biggest concern areas is around lithium, and that's because we need such a large increase in the amount of lithium relative to the lithium market today. On these graphs, we're showing on the top the total potential supply for these materials. And this is based on current projects, planned expansions of those current projects, recycling, and new developments with a little bit of risk weighting built into it. When you add all those up, they're just about able to meet the growing demand, assuming a particular share. Our forecast for what the demand is going to be by different battery chemistry, and translating that back up the value chain. Now, if there's any significant delays to the developments of new projects, if some of these resources don't actually get developed on time, you could easily see or envision a world where we're in a shortage of supply. Nickel's a similar situation to lithium in that it's also a high-risk area, but there's further complexities within the value chain because there's different grades of nickel to consider, and there's different conversion costs of bringing those different types of nickel resources up to battery grade. When you add it all up, though, although there's a lot of nickel that gets used for the stainless steel industry, for example, the amount of nickel available for automotive is, again, a supply constrained world. Cobalt makes a lot of headlines because it's only available in certain locations, and it's also available as a byproduct of certain other mining operations, whether it's copper or MHP processing or others. And so there's a lot of other risks inherent in the cobalt supply space. But in terms of supply-demand balance, it's not as constrained as lithium and nickel potentially are. This gives a view of that geographic dispersion. So when you look at the metals that are, or the resources that came out of the grounds, this is in 2022, you can see lithium was really driven by Australia and Chile. China accounted for just 15% of that. On nickel, that's Indonesia, Philippines, Russia, and then it's a little more dispersed after that. Cobalt is heavily concentrated in the Democratic Republic of the Congo. And then natural graphite has been primarily coming from China. Now, this is the view of the things that are coming out of the ground and where they're coming from. Then there's the view of the refining. So China has an outsized share of the refining capacity across each of these. Right? Largely that's because they've been serving the Chinese EV industry, which has been a bit ahead of the curve. Now, as part of this, and we'll talk in a sec about what companies are doing to secure their supply chains, it's important to remember this dynamic. The Chinese companies needed the material, and they went out and they've started to secure it and build relationships with these resources that are distributed around the world. So that has certain implications when you think about policy and geopolitics. So last year, the US came out with the Inflation Reduction Act. And one of the basic premises of this, in addition to try to spur economic development and to encourage consumers to buy EVs, was also to achieve some level of energy security in response somewhat to these dynamics that I just talked about the Chinese companies having an outsized share of the ability to process and also control a lot of these resources that are critical for EVs. So when you break down the Inflation Reduction Act, there are a lot of different pieces to this, but some of the most that are important for the automotive industry are, first, there's a $7,500 new vehicle, clean vehicle credit that gets talked about the most. So that's probably what you've heard about if you've read about this just a little bit. And that's broken down into two parts. There's, half of that's given if you meet the critical minerals requirements, half of that if you hit the battery components requirements, and we'll talk a little bit more about those in a second. What gets talked about a little bit less is the 45X manufacturing tax credit. And this is a significant tax credit. It provides $35 per kilowatt hour on a battery cell, on the production of a battery cell, $10 per kilowatt in an increment to that for the module assembly. And then also provides 10% of the costs for processing of critical minerals and production of what they call electric EAM, which is electrode active materials. There's also a used vehicle tax credit. There's a commercial vehicle an analog of the 30D, which actually can be used in some ways to provide a little bit of a loophole in some of the requirements. But there's a lot of other complexities here. This is a relatively simplified flow sheet to say, do you qualify for those that $7,500 consumer tax credit? First, you need final assembly of the vehicle to be in North America. There is household income and car price restrictions. And then there's this clause called foreign entity of concern. The foreign entity of concern clause is the piece of this bill that is intended to target exactly this geopolitical issue with China and the US energy security. And the notion of this foreign entity of concern clause says, if any of the critical materials are coming from a company that is controlled by, subject to, or under the jurisdiction of, or subject to the jurisdiction of a foreign entity of concern, being Iran, China, North Korea, and Russia, then the vehicle is not subject or is not eligible for the tax credits. Now, in addition to that, then they add these two pieces. So the percentage of components, battery components that are, and then the percentage of the critical minerals that are extracted or processed or recycled in a free trade agreement country with the US. The required percentages for these escalate over time, and there's a lot more nuances I can get into. But suffice it to say that the IRA is a landmark piece of legislation, provides an incredible amount of funding to develop the supply chain and to incentivize purchase of EVs. And it has these restrictions tied to it to promote energy security. This is just a deep dive into the 45X and what it's applying to in the value chain. But I said that these were significant subsidies. If you just take that $35 a kilowatt hour and you apply it here, along with the $10 per module, so you have $45 per kilowatt hour. And again, if you just do the math on take that times 100, that's the potential subsidy that you have, right? That's $4,500 per vehicle, on top of the $7,500, on top of the used vehicle, on top of other benefits that you can get in the supply chain to subsidize your investment and through DOE grants, et cetera. It's an incredible amount of money per vehicle that you can get. This just shows how significant that is in the relative terms of the cost of the battery. So you can create a high nickel, which is the more expensive type than LFP, high nickel battery in the US, much, much cheaper than you can produce an equivalent battery in China. In fact, you can actually get below the LFP landed cost in China. This is again before, let's say, major Chinese subsidies, but you can produce at a lower price point a nickel-based cell in the US versus a China LFP cell being imported. So what are companies doing along the value chain to respond to this? There's a variety of different strategies. But basically, they all revolve around getting more involved in the midstream and upstream. So taking a heavier hand in working with supply chain partners, not just their direct suppliers, but investing in mines, securing raw material supply agreements, becoming educated, developing internal teams that understand the geology and the resources and also the underlying technologies that are going to be required to make the right deals and make the right investments. This is a snapshot as of last year, actually, of various raw material deals for lithium, nickel, and cobalt. And it's broken down into whether they're investments or LTAs. And these are all made by cell makers or OEMs. And you can see here that when you just take the publicly announced deals, it actually accounts for securing over 40%. This is as of a year ago, 40% of the required material or production of these materials by 2025. But as companies become more and more active in the midstream and upstream for these materials, it does bring new risks, particularly along ESG. It's very difficult to get a lot of transparency into what the risks are embedded in this. These are just a few examples. So if you're buying nickel, a lot of nickel comes from these open pit nickel mines, which can be very highly polluting in Asia. There's a high potential for contamination in groundwater, and any kind of open pit mining doesn't look like the cleanest operation if you see it in person. Even lithium, so lithium that comes from brine that's getting evaporated. Even if you were to do it with fully green energy, remember that a lot of these lithium deposits are coming in are found in places with relatively little water. So if you look at Salar de Atacama in Chile, in the Atacama Desert, which is Chile's largest, by far the largest lithium reserves, they're actually paying off the indigenous communities locally, and they pay a certain amount per household for the water rights, and they're pumping thousands of liters of water per hour to ensure that the operations are maximizing what they can get from them. But there's a scarcity of water available for the community as a result. There's also the opportunity for tailings, and then something that doesn't often get talked about is that if you have sodium sulfate from the precursor process, normally sodium sulfate, it occurs naturally. It's in the oceans. If you're dumping it into the oceans, it mixes in fairly quickly. If you're dumping it into sweet water, that's a huge problem. And also, we don't really know the impact that can have ecologically, dumping it in a concentration that's very high into the ocean, around particularly that localized area. So these are just a few highlights of the things that can come. I mean, the one that people highlight the most is potential for child labor, and the DRC and other places. So this is the world that automakers and cell makers are entering into and stepping into as they sign up for becoming more involved in their supply chains. So key takeaways from this talk. First, electrification brings a lot of new complexities to the automotive supply chain. The dispersion and scarcity of certain raw materials, especially lithium and nickel, but others included, needed for lithium-ion batteries create risks and geopolitical tensions. And these concerns have exacerbated geopolitical tensions, prompting the US to pass the Inflation Reduction Act. And we're going to see probably some similar responses from Europe. China is also taking note. And meanwhile, OEMs and cell manufacturers are becoming more involved in the upstream to address supply, pricing, and geopolitical risks. But this too has its own drawbacks, not just the capital, but also taking on a new level of ESG risk. All right, and with that, I want to thank you for your time. Any questions?
Thanks, Isaac. Let's do some Q&A. Now you talked about and we've taught, and it's kind of common knowledge now because people have been talking about it for so long, a couple of years, about these choke points in the materials and processing within, especially in North America, right? Because they're really, I think it was, Tesla just was the first company to actually open up a processing plant in the US. GM just did a deal for a manganese processing plant in Louisiana. How long do you think it's going to take to overcome these choke points within North America?
It's hard to say how long the choke points are going to last. I think it's important to peel back from that, how much of that processing actually has to happen in North America or the US. And so, part of the Inflation Reduction Act was targeting extraction or refining in a free trade agreement country with the US. So that includes Chile, includes Morocco, includes South Korea, and others. So I think there's room. It doesn't all have to be self-contained. And the reality is that not all the resources appear naturally in the ground in the US. We can't do it alone. So it raises a bit of a different question that says, well, to serve the US automotive market, the North American manufacturing market, we need to be drawing on resources available from a broader set of countries. Exactly what that set of countries looks like and how that develops is something that is really up to the industry in the end, because the government doesn't like to kind of dictate that level of detail in terms of how it gets, how the industrialization happens. But in general, I think until we have a game-changing advent in the battery technology that completely alleviates this, or if we have a fundamental difference in market expectations, I think the situation is going to remain very tight for the rest of this decade, and perhaps a little beyond into 2035. And it's going to be a while until recycling can really take a major role in alleviating some of the supply constraints.
Very good, thank you. You were talking about the EV penetration. How do you expect an EV penetration of greater than 40% by 2030 without significant reduction in overall vehicle sales? You know, the concern of the supply chain constraints, the charge points in big cities, things like that.
Yeah, it's a great question. It's a topic that we always debate. As I said earlier, we tend to be on the bearish side of that outlook compared to other forecasts that are out there. There are a lot of challenges to overcome in terms of user experience. You know, the issue is not how much range can you put in the vehicle. The issue is what are the consequences of when you are low on range? So how inconvenient is it to charge up? Some people can have a charger at home, some people can't. Public charging remains difficult. The time to charge is a perennial issue. At the same time, a lot of people have a terrific user experience, right? They like not having to ever go by the gas station if they can just plug in at home. A lot of vehicles don't need that huge amount of range, you know, for 95, 96, 97% of daily drives. If you have multiple cars in the household, you don't need that much range or a combustion engine range for every vehicle in the household. So there are a lot of things kind of interplaying into this. Supply constraints are going to be a big one, but there are some technology substitutions that can help alleviate the issues. If, for example, you use LFP, then you reduce the amount of nickel you need. If you were to come up with a high manganese battery, it would again reduce the amount of nickel. As you have higher energy densities in general, you reduce the amount of lithium that you need. And alternatively, and Toyota likes to beat this drum a lot, is that plug-in hybrids get a lot of bang for your buck. If the consumer is plugging it in regularly, then for the amount of resources that you're using, raw materials you're using, you're getting a lot of CO2 abatement.
Very good, thank you. For the 45X tax credit, does that include Canada and Mexico?
No, 45X requires US production.
Okay, that's what I thought. Okay. When you talk about the different, you kind of talked about, you have a slide where you talk about different types of companies and their strategies, right? For how they're approaching. I think it's more, is it development of batteries in general?
Or how their approach to interacting or partnering
Yeah,
across the value chain.
yeah. From your perspective and your research, have you seen one particular pattern that you think is going to be more successful in the long run?
I think the right strategy depends a lot on the OEM or the cell maker. It depends a lot on your volumes, your position in the market, your general philosophy in terms of make versus buy and technology and sourcing. So you see a full range of spectrum across OEMs. There's no reason why a smaller OEM or premium maker should be investing that as much. There's certain economies of scale to developing the internal capabilities in-house. And so I think it's difficult to say what's the winning strategy. I think it's more about coming up with a flexible strategy that can adapt as the market develops, because everything changes on a dime these days. So policy changes, trade wars, technology breakthroughs, anything can really swing the market very rapidly.
So when you talk about being flexible, what does that mean? How do companies stay flexible when the amount of investment that's needed for, saying, doing something in-house versus outsourcing? How do they, what makes sense in the long run?
Yeah, I think you can measure flexibility along a few different dimensions. So there's powertrain flexibility. So, are they all into EVs? Are they, leaving their options a little more open? There's technology flexibility in the batteries. Are they going to go, are they committing to one particular partner or one particular type of cell technology? Are they signing up big time with certain strategic partners, whether it's battery startup or a cell partner, or even raw material supply agreements? You're potentially with each of those types of partnerships taking on a certain amount of risk, but you're also addressing other risks. And so it's finding that balance point and hedging your bets. And the biggest OEMs are, so they are spreading their bets across multiple cell technologies, multiple cell partners, multiple types of startups, ventures, junior miners that they're engaging with.
So you heard from Jingwan about their strategy for going after certain kind of cell technologies now and in the future. How do you see that strategy compared to how other companies are approaching this?
I think LG is approaching it very much like the other large cell makers. I think a lot of startups garner a lot of attention and headlines. They make big announcements about solid state and their plans to commercialize new technologies. But at the same time, every major cell maker is also pouring billions into R&D to develop these same types of technologies. They're also aware of what else is on the market. And so I think in general, it's a similar path. We could talk about different chemistries and focus areas, but no, I don't think it's out of line with any of the other big cell makers.
Yeah. I think the most recent announcement was it a CATL announcement about a battery that's going to have 600 kilometers of range and be able to recharge within 15 minutes, that kind of thing. And they actually have announced this for it's probably a few months old now, but do you see that as something that's going to happen within the next, say, 5 years?
I think it's always difficult to say. I mean, CATL is probably one of the more credible players out there. On the other hand, you have to take every new battery innovation announcement with a grain of salt. So one of the ways to read any new battery breakthrough technology announcement is look at what parameters they are highlighting that they're improving on, and then whatever they're not highlighting, that's what they're facing a challenge with, right? So if it's energy density and range, then okay, maybe it's life cycle, or if it's not that, then maybe it's cost, or if it's not that, maybe it's operation at low temperature. So there's a number of different parameters that you have to factor in evaluating whether that technology is suitable for the EV application. And usually when you peel back some of these announcements, right, that you end up finding that the advancements are a little more incremental than game changing as they might at first appear.
Very good response. It has a lot to do with announcements of any kind by a manufacturer or supplier, right? Trying to figure out what are they really saying. Now, when you look at I want to ask you the same question we asked Jingwan. Can you see the auto manufacturers doing their own development of cells and production of battery cells?
Yeah, so a lot of them already are developing battery cells. Tesla is a little ahead in terms of manufacturing. There's a lot of JV partnerships between cell makers and OEMs, although it's important to acknowledge that there is a bit of a division of labor in who's bringing what to that partnership, to those types of partnerships. I think right now most large OEMs are planning to either insource or semi or pseudo insource more of the battery technology going forward. On the other hand, we always, typically as we see new technologies introduced to the automotive space, we always see this pendulum swing of OEMs like to learn more about it. They want to understand it better. They want to invest in, and they view it as differentiating. And then there's a time when they either realize it's really difficult and they want to leverage the supply base, or they say, okay, I understand it. I feel like I've mastered it, but I feel like it's probably a more efficient deployment of my capital to outsource this. And so we see that pendulum swing through cycles of the automotive industry over the decades. And I would expect that we'll see that pendulum start to swing back in the coming years from OEMs.
Very good, thank you. The lithium ion spike, was this market speculation driven or supply and demand driven? Should we expect it to normalize back to 2020, 21 levels?
Yeah, I wish I knew the answer to that, because then I could place some bets. I think the in terms of what was the root cause of the price spike, I think it was a combination of both. So first of all, recall that a lot of the lithium that's out there is getting tied up in agreements, and offtake agreements, long-term agreements, or is captive. And so what you're seeing is tradable on the index, and the index price is a relatively thin cross-section of the lithium that's out there. So that means that you're subject to a large amount of volatility because only a certain amount of the lithium out there is getting traded. We could also talk about, probably, it's worth having a further discussion at some point about, what are the price setting mechanisms? How do they actually come up with that index price? Because usually for any kind of commodity like this, that's not publicly traded, you end up having to basically call up a bunch of folks who are traders and ask their opinion. So there's all different kinds of minutia that can impact these types of price fluctuations. So I can't say whether it's all speculation or all supply demand driven. It's a bit of both. I think everyone recognized the tightness of the market. There were a lot of customers downstream that were relying on supply, and you don't want shortage of a raw material to not be able to allow you to sell a $40,000 or $50,000 vehicle. So there's a lot of stakes involved. So when people are desperate and there's contracts that require delivery, people are willing to pay for those short terms, and then you get introduced to speculation on top. So in terms of where it's going, I think a lot of it depends on that supply demand balance. It's going to remain at best tight in terms of how it looks. If there is a real shortage, then we're probably going to see some switches in technology to try to mitigate the demand side. But on the other hand, you could very easily imagine a world where, after a lot of these new developments come online, that the prices start to normalize out around producer economics. Or if you look at the contracts that OEMs and cell makers are getting, their actual prices paid might look a little bit closer to producer economics at the marginal level for some of the relatively higher cost lithium deposits.
Very good, thank you. For the Investment Act, does this only impact battery chemistry, manufacturing, and materials? How does it affect investment in battery structures, lightweighting, and safety issues, if at all?
The Inflation Reduction Act does not directly address lightweighting and other forms. I think but when you take that combined with the proposed EPA and CAFE requirements, right, you have to consider this in a context. So the Inflation Reduction Act and various measures from the DOE in terms of loans and grants are all helping to bring down the capital requirements and bring down the cost of EVs. At the same time that you're going to have smaller, or let's say diminishing volumes on the combustion engine side, and tighter emissions requirements, which is going to bring up the cost on the ICE side. So when you take those into account, like there's going to be some level of dynamic in there. Certainly, as you have electrification as a lever, and that becomes cheaper to deploy as an OEM, lightweighting becomes a little less attractive. If you rewind the clock back to 8 or 10 years ago, a lot of OEMs were planning on relying more on lightweighting and a little less on pure BEV. And of course, that's changed fundamentally in the last 6 or so years.
All right. Last question. One of the articles that I was just reading was focusing on environmentalists and their response to EVs and their response to the issues that you mentioned about the issues of environmental degradation for mining and particularly about mining all the different materials. The article was making it sound like it's kind of a conundrum for environmentalists because they want to have a clean process. But if you believe in climate change and the clock ticking, you can't wait and you can't delay these things in a way that it makes you not meet your goals. How have you been seeing the environmentalists respond to the things that you were talking about?
No, I think there's a range of different views towards or there's a lot of complexity answering the question of what's the best approach environmentally. Yeah. I think personally, I believe it's myopic to hone in too much onto one issue, of to say, this one mine is a problem or this one, aspect is an issue. When you're considering the requirements for decarbonization to have a science-based target or to limit global warming to a certain number of degrees C of warming over the next 50 or 100 years, you have to look more holistically. So there are a lot of straw man arguments that I think fall down very quickly if you hone in too much on one particular part of the value chain, or if you say, well, the grid still needs to decarbonize, so what's the point of switching to electric? Well, those are two separate problems that, ideally, if you want to mitigate the amount of greenhouse gas emissions, you have to address both of those together. So it's up to the auto industry to do one, it's up to the energy sector to do the other, with regulation helping. And so again, I think a lot of the complexity comes from the fact that there isn't that much transparency, and it's tough for folks who are commenting on the space or used to advocating for a certain type of policy, I think, to get a holistic picture and put it all together, right? What is the impact of, and it's a world of trade-offs. What are the environmental impacts across a range of dimensions, not just GHG, but other things as well along the ESG spectrum? What are the implications of mining, refining, et cetera? What are the methods used? How much controls and oversight is provided in those processes? Transportation gets overstated as a contributor to GHGs. It's actually a small single-digit percentage, the contribution of the GHG footprint of a battery. Even if you're shipping materials intercontinental multiple times, still is fairly trivial. But then you get into the use of the product sold, and the fact that you're charging an EV with electricity, it depends a lot on where you're charging it. What is the marginal electron that you're purchasing? So it all gets very complicated very fast. And for anyone, even folks embedded in these issues within the industry, it's difficult to put together a holistic model to really weigh the trade-offs effectively. And so I think that's part of the challenge of having an effective discourse in this. And everyone's used to having a certain point of view, but bringing it all together is a big challenge.
Very good. That was a great answer to a challenging question, Isaac. Thank you very much. A great presentation. There's you had some really good stuff in there that you didn't talk about in detail just because of the time constraints. But anyone who looks at the slides and the video will be able to really drill down and look at some of the other detail that you have. Thank you very much. We're going to take a break now. Welcome back. All right, for the second half of the conference, we'll be talking about some of the survey results from our EV Challenges and Opportunities survey, and then Kara Elkhire will talk about the work that she's been doing over the last 3 years or so about tracking the investments in battery cell production in the U.S. in particular, but some in North America as well. For this particular project, we were looking at for what we're taking out of this, and we're really looking at as issues related to batteries in particular. So let's look at some of the issues that survey results that we saw from this. So of course, our sponsors are the ones that support not only our conferences, but also our research. So we have a set of survey experts, automotive manufacturers, suppliers, government officials, NGOs, academia, and consultants, asking them about their opinions on the different topics. We asked predictions for potential EV challenges and opportunities, including future market, manufacturing, vehicle safety, charging, and government support. And we did the surveys in March or April this year. This is the distribution of the manufacturers and the titles of the respondents. Notice the significance level. That's something that we do to compare the responses from manufacturers and suppliers. And the other group, which is a combination of academics and government NGOs and consultants. You're not going to see I don't know if you're going to see any differences between those three groups on this survey. It was pretty unusual that all three groups there were no statistical differences among those three groups, which is very unusual. We usually have, when we do this analysis, we'll have a number of differences between the groups. The other thing that we do that's kind of unique for our survey is that we weight the responses of the respondents by their confidence in their estimates. Now, this, of course, is their own view of their confidence in their response, and that could vary by individual, but it's something we do as a way of giving a little more weight to the experts who are a little more confident. So, market overview, not necessarily a battery question, but here we're looking at what they're predicting for percentage of US EV sales in 2025, 2030, and 2035. As you can see, they're not even close to meeting the government goal of 50% of EVs by 2030. But this is pretty much in line with some of the more conservative views on where vehicle sales will end up. We asked some open-ended questions, and one of them was, why are EVs too expensive for the typical new car buyer? Well, of course, you can see the representation here is that they're too expensive compared to ICE vehicles. They're premium only. They need lower end models. And the third biggest thing is our battery costs. So you can see this is where batteries come in for this particular question. We also asked for every set of questions, we asked for comments from the respondents, and we selected some that we thought were particularly cogent. The production tax credit, which we heard about already, for up to $45 per kilowatt hour for the batteries, will have a major impact as it drops battery prices by over a third. And another response was, it seems battery manufacturing capacity, number of chargers, raw materials, electric grid are all scaling up, but we know there will be some issues and it's hard to predict where. And I think from our comments that we've had so far on the conference that's pretty reasonable response. that there's a lot of uncertainty in what's going on. When we talked about Tesla, the number one EV company in the US, what are their biggest challenges over the next 10 years? Number one thing would be competition from the other manufacturers, more, or the need for more and newer models from Tesla. And then the third thing being the battery technology and the raw materials. So again, this is where the battery also comes into play. In terms of comments, despite nearly 100 comments on the challenges facing Tesla over the next 10 years, a few comments really made an impression. One was, for Tesla to continue to be in fashion, it will continue to take expert marketing, but that's what they seem to be good at. And the other one was, there's always Tesla's always seems to be 2 steps ahead. The legacy automakers can catch up, but it will take at least 1 or 2 generations of vehicles before that happens. Over-the-air updates, dealer direct sales, gigafactories, gigacastings, supercharger networks, scale, vehicle efficiency, heat pumps, subscription services, infotainment, and global footprint are all impressive. We had some questions about EV manufacturing related to batteries. Experts think it's going to take about 6 to 10 years for US battery companies to be competitive with Chinese battery companies. And over the next 10 years, experts expect to be difficult for manufacturers to develop their material supply chains. And some of the comments in particular about China, China is still strong in battery market, no matter how the US government regulates the battery sources, because they can sell more EVs in China. When you have a built-in market that allows you to sell vehicles there in that market, you will always have an advantage. In terms of charging, and this is something I thought was kind of related to something that Isaac was talking about in terms of when we were talking about charging. And it's one of the issues where, we need all these charging points out there. Well, here the experts are saying 3/4 of the people are going to be charging at home. And in 2025, a little less than 3/4 in 2030, as more people who maybe don't have homes where they can charge become part of the vehicle fleet. But still, 70% of people charging at home. That tells you a lot about who they think is going to be the buyers of EVs between now and 2030. It's going to tend to be people who have single-family dwellings, have ability to have chargers in their homes. They think that the charging station companies, the public and private companies, won't be profitable until the end of the decade, which is kind of an interesting story when you think about the investment that Tesla has made in their supercharger network, and the continued growth of that network and the growth of the other networks. If it's going to take until 2029 or 2030 to 31 to actually be profitable, can companies last that long? It comes. I think it's going to come out in our discussion of the investments that Kara is going to talk about in her presentation, that there's going to be so many companies that are in the game, at least at the moment, and with support, government support, will they be able to stay in the game? Will they still be able? Will they be able to last? And I think this is there's going to be some challenges along the way for all of this. They think that experts predict that it's likely that traditional oil and gas companies will expand their business to include electric vehicle charging. I was a little surprised by this response. I thought that I haven't seen the traditional oil and gas companies doing anything in this area. I may be missing something, but they seem to be going in the direction of e-fuels now. where if you use green energy to generate the fuel that's used in vehicles, you get credit for that, and that allows you to continue to survive as a traditional oil and gas company. The e-fuel story really has played a bigger role in Europe because of the regulatory agencies in the EU that were forced by the German government to add e-fuels as a possibility for the vehicles after the supposed 2035 deadline for not selling gas vehicles after 2035. Now, this was a big legislative issue within Europe. They were very proud of this, but at the last minute, the German government forced the EU to, I guess they haven't quite finalized the regulation, but they forced them to to allow e-fuels to be part of the discussion. Now, e-fuels is to me, when I was hearing that, it really was kind of a gimme to the oil and gas companies because it keeps them in business. Because if you're selling if you're no longer selling gas vehicles in 2035, then you don't need gas. So it gives them a lifeline, and it allows potentially gas vehicles to be in play indefinitely, and it'll be a really serious challenge to get them off the road then, if the EU is really serious about doing that. So when you look at some of the charging comments, the one that stood out to me was charging stations will need subsidies to go into low density environments and will be subject to grid issues and local electric utility pricing issues. Profitability will be limited by the pervasive option of at-home or fleets-based charging. And I think this came out in our conference, I think it was in February with New Mobility, where we were talking to the Ford Pro group and their strategy for having fleets change over to EVs, which we thought was it's kind of almost a low-hanging fruit for the EV industry to be part of probably not heavy truck, but smaller trucks that are more local, that come back to the base every night to recharge, and gives them the opportunity. And Ford at that time was talking about having a full system of having available and setting up the charging stations, the software to follow your vehicles wherever they are, and to follow them through the process of where they are charging, how much they are charged, and how the vehicles are being used. So it was a real kind of an eye opener for us to see how the fleets may be the more besides the luxury brands being able to take advantage of EVs. The other issue had to do with the utility pricing issues. This is something that we're very used to when it comes to gas stations. So you go to a gas station, you can see the price of the type of fuels that are available. When you go to a charging station, you have no idea how much it's costing you to charge your vehicle. They may say it once you give them the card and you're ready to charge up. You may have a choice. If you want to not do it, but you're probably there because you need to be charged. And the differences between the cost of charging at a charging station, which if those charging stations want to be profitable, there's probably going to be a markup, a certain amount of a markup for them to allow you to charge there, unless there could be government subsidies for this, as an incentive to get things moving. But compared to your at-home charging, and there again, certain times of day when it's more optimal for you to charge it there, is always probably going to be cheaper than at a charging station. But it'll be interesting to see when those pricing issues come to the fore for charging stations, so that someone could start saying, oh, they're going to be charging this much for a charge. How much are these people charging for a charge? And for the same thing, for the same reason that we will change gas stations for a few cents per gallon, that may be something that will end up happening with charging prices. We're looking at vehicle safety. They thought that experts thought that battery fires are particularly a particular safety challenge for electric vehicles, and we've seen and heard about the manufacturers trying to address this issue. They're trying a variety of different technologies, LFP being one of them, where you have less likely to have that vehicle start on fire during charging. But in terms of what we've seen on the road, particularly the General Motors Chevy Bolt problem with fires, became an example of what can happen with vehicles, but it also was an example of the traditional manufacturers understanding how to deal with an issue like this. Reminds me of the Ford Explorer rollover in the early 2000s, where they said, we're just going to replace all those tires, and then start redesigning the Explorer to be less likely to tip over. But so they just said, we're just going to replace, and GM said, we're going to replace all those vehicles. And the tricky thing was, one of the things that they notices that they issued to all the Chevy Bolt owners was that please charge your car outside of your garage. Well, that's assuming your charger actually could reach outside of your garage to be able to charge it. But that was one of their strategies. But kudos to them for actually understanding that our reputation is at risk here, and we have to fix this. So that, I think, was a very impressive response from them. From the safety side, the comments, it said the industry hasn't begun to realize all the safety issues that will be embedded in such a significant change in how vehicles are propelled. Most of the key safety issues in conventional propulsion systems were only realized through decades of billions of miles real on-road experience and driver use and misuse. Our abilities to simulate, predict, and validate are better, but still not effective enough to prevent all safety issues. And I think that I thought that was particularly important response about what we will see in the future about safety issues related to EVs. From ESG side, experts think that battery recycling may be successful by 2030. They're leaning towards a little more to be successful than not successful. So they're expecting recycling to do better. And we define success in this case as a high percentage of our recycled EV battery materials used in new EV batteries. And the experts thought that battery recycling will be profitable by the next decade. So the battery recycling itself. Now, again, there's a number of companies. Kara will talk about this. Probably we'll talk about some of this in the Q&A with her. That there's a lot of investment in recycling facilities. We see and we asked Jangwon about that, and that that the Koreans are bringing their own recycling companies and to set up nearby in the new plants that they're building in the U.S. So that that becomes a process, but to be profitable is a whole nother story. And they need that volume to be able to be profitable and make it work for them. So I think that's one issue that having the volume to be able to do enough recycling to make it profitable will be the issue as we move forward. And in terms of the comments for this, battery recycling will only contribute a meaningful proportion of battery materials once there is a large installed base of EVs that have come to the end of their useful life, and that will take decades rather than years. So this kind of contradicts the story of them being profitable in the short term, because decades is a lot longer than the 2030s. So I think those are some of the responses to our survey and questions from our survey that are related specifically to batteries. I'd like to take questions from the audience. You don't have to write them down. You can come up and ask if you have any questions about any of the things that I've been talking about. Critical mass of CAM required for recycling to make a significant impact in the market. Okay, it's the material, it's the active materials that are used in lithium-ion batteries. Okay, critical mass. Yeah, I don't think anybody has done the math on this yet. This is, I think, early days. I'm sure some of the recycling companies probably have some estimates about that, but it has a lot to do with their customers, right? And how much are their customers willing to pay for the recycled mass, right? And that will probably determine a lot whether they're how successful they're going to be. But some of the recycling companies are are directly tied and invested in by the manufacturers, so that you could see that they might actually, I could imagine the manufacturers carrying them for a while they're trying to get the volume that they need to be profitable, because the manufacturers probably see it as a direct feedstock for them to make their next set of batteries. This is probably true for some of the major battery manufacturers as well. The LGs, the companies of like that of the world. So they're probably interested in getting that as well. So could we see either the battery suppliers and or the auto manufacturers supporting them for a while? I think that's reasonable, because it's kind of like in for a dime, in for a dollar. You've already set them up, and you really don't want them to fail. You want them to be able to survive. So how long that goes, that's a whole nother story. It could be a really long time. Exactly. Yeah. The second life story is something that we've been discussing as well, that it delays that recycling of that battery. It's probably depending on how they're used. We've heard a lot of the potential uses for second life batteries, but we haven't seen. I don't know if we've seen a lot of studies that say, okay, this is really working very well, and actually, I think Kara can talk about a little bit about this. She said it has to do with whether the second life batteries are actually working as people were thinking they were. The question is the extremely long lifespan of a battery if it gets into the second use, and that it could be 20 years before that battery actually becomes recycled. That's a potential scenario, but I don't know if there's enough research to say that is going to be a common scenario, and that you'd say, well, maybe that might happen, or maybe they find that those second use strategies are not as strong as they thought they were, right? I don't think we know yet about how that's going to play out. All right, other question. What are the U.S. battery companies? One of the questions asked, when will U.S. battery companies be equivalent to the Chinese battery companies? Good point. There are not. I don't know if there even are any named U.S. battery companies that we could invest in at the moment. I think Kara will be talking. She's shaking her head like they're not there. Isaac, are there any U.S. battery companies? Yeah. So Isaac was saying that these are most of the are small companies and startup companies that are really. I know when the research that we've been doing for a number of years, a lot of R&D companies, a lot of companies doing R&D, but no mass manufacturing in the U.S. yet. So it makes sense. There's either all JVs, the Korean, the Chinese companies. Tesla is probably the only one that's actually doing some form of battery cell manufacturing. Yeah, and yet, but theoretically, they have the scale to if they have enough, if they find that it's viable and profitable for them to do that from their research and their technology development. They're probably as we described in some of the other comments, they've been first out of the box for a lot of things, and it could be for this as well. Good point. Any other questions? For second use, I think the comments that I was showing, I think were probably it. That it's going to take years. This is the one that kind of stood out. There were some others, but they didn't kind of strike me as something that, wow, this is something I really want to share with the group. I think it's just because of that we're still early on in the recycling story, as we are early on in the battery story, right? This is all it's all pretty new, though. One could argue we've been recycling lead acid batteries for decades, and actually doing it efficiently for decades. So it wasn't like we'd never done any recycling at all. This is just a whole nother level, right, of recycling. And I can't help but think that the recycling that they're developing or have already developed or are developing for the EV batteries really learned a lot from the recycling of every other stuff that we've been recycling for a few decades now, right? So I think one could argue that if we had never done any aluminum recycling, we had never done any kind of recycling that we've already do, and actually do quite well. I mean, the steel and aluminum industry use the output from the recycling of those materials and have been doing this for decades now. So I think that was a real advantage when we started talking about this, so that you're looking for separating materials, and they've been separating materials for a long time. We did a study on vehicle plastics recycling, and this was like late 1990s. So and companies were already doing this. They were struggling with it because of the different types of plastics, right? But they were making progress in this area. And of course, in the metals, they had pretty strong progress. So it really wasn't like this was a completely new story when they started saying, "Oh, now we want to do this." How they did it probably was unique. How do you separate lithium and cobalt and graphite from within the battery? But I think it's based on a lot of recycling strategies that we already have. Good question. Let's go to our final speaker of the day, Kara Elkire. So Kara is a senior research associate here at Automotive Futures, where she's currently focuses on the North American battery value chain and relationships between OEMs and EV battery manufacturers. She designs and compiles unique research, analysis, statistics, surveys, and interviews for client projects, and reports distributed and presented throughout the automotive industry. Her research focuses basically on the direction of technology growth in the auto industry. Now, prior to joining Automotive Futures, Kara worked with me at the U of M Transportation Research Institute. And over the last 20 years, we've done research projects on everything. We did manufacturer-supplier relations. We did manufacturer-dealer relations. We did the entrance, even a little before us, was the entrance of the Japanese into the US auto industry. And Kara did presentations related to that. And more recently, she's worked on some new safety technologies for heavy trucks, as well as the total cost of ownership of diesel versus gas vehicles in the US. She received her BA from Miami University in Ohio and master's from public policy from the University of Pittsburgh.
Thank you, Bruce. So again, I'm Kara Alkire. I'm usually behind the computer, not behind the podium, so please bear with me. So I'll be discussing our ongoing research on EV battery circular value chain that we see developing here in the US. I'll talk about the drivers, the elements of the circular battery value chain, some OE examples, and look closely at battery cell manufacturing and how that's developing here, and some final thoughts. And this is all review from everything we've learned today. So I'll just note that going forward. We focused on two drivers to develop the domestic, that are developing the domestic EV battery value chain. Isaac clearly went through both of them. The first one, global competition and the dominance of China. And this is one of my favorite articles for anyone out there who likes some diagrams. Okay, so this New York Times article really goes through every step of the supply chain that China clearly dominates. They own the overseas mining, the refining for cobalt lithium is centered in China. Cathode materials, 77% in China, anode materials, 92% centered in China. They dominate every level of the supply chain. We've had a lot of lessons in risks in the supply chain over the last few years, and to reduce the over-reliance on China and the risks in the supply chain and promote U.S. employment. The Biden administration passed several policies to help develop our domestic value chain. And this is one, Isaac's been through this, the Clean Vehicle Credit Program requirements. I actually made this chart for me to help me keep clear the details of the ramping up of the requirements. So what this credit program does is, if the manufacturers follow the sourcing requirements for critical minerals and battery components, their consumers will receive a benefit, a rebate basically when they purchase an EV. So GM and Tesla were the only two OEMs to have all their EVs qualify for the full $7,500 credit. So what I believe we're seeing when we look at the supply chain development and how this particular program is influencing it, we're seeing consumers being maybe influenced to buy an EV with the rebate that they're receiving. We're seeing every level of the supply chain trying to source the manufacturers with compliant projects. So we're seeing that. We're seeing manufacturers locate here, their EV manufacturing here, if it's not already here, so that they can be compliant and their consumers can receive these benefits. And we're also seeing the US government go and talk to our allies and free trade partners around the world to develop new critical mineral sourcing to help supply our industry here. Okay. Also, 45X, the Advanced Manufacturing Production Requirement Program, that's also part of the Inflation Reduction Act that is seen as a big win for the manufacturers and the battery manufacturers as well. As Isaac said, they believe that it's cutting the cost by about a third of manufacturing the battery packs here in North America, and that is causing perhaps tipping the scale. So manufacturers that were planning production in, say, Europe are putting that on hold perhaps and moving that here. We're seeing enormous investments here. I believe it's also fueling the momentum that we're seeing. Tesla expects to earn up to $1 billion in battery tax credits this year. Ford claims that they could receive $7 billion in the next 3 years, up to 2026, through this program. Let's see, I do think as well, it has to do with the critical mineral production and the cathode, anode materials and such that go into the production of the battery material. These credits go to manufacturers, so that's different than the first one that I went through. We're seeing this influence the development of the value chain here. So I'll go through briefly some of the elements of the value chain. Raw materials. We do have some of these critical raw materials in the US, but over the last several decades, we haven't focused on sourcing them ourselves. We've gone abroad and done that. We do have one mine operating here for lithium, Albemarle in Nevada. There's several more, maybe 3 or 4 or 5 more that could come online in the next several years. But again, we're going to be looking at our free trade partners and allies for help sourcing this. Materials processing and refining is the next step in the value chain. And cell component manufacturing, including cathode anode materials, for example. These 3 steps really have not existed in the volumes to supply a domestic industry here. And we see alliances and agreements and announcements for several of these steps to start locating here. We see companies that are in the raw material business, the big global mining companies, perhaps expanding their operations to refining because there's an opening there and there's money there. We see some of the large chemical companies that are processing and refining materials, perhaps moving in and doing more to make the battery grade materials. We see, again, openings in opportunities for companies to expand and lots of investment. So battery cell manufacturing, I'll go through that in a little bit. Battery assembly is a step in the value chain. We're seeing a typically that's been done by the battery manufacturer, and that's taking the cells, putting them into modules, the modules into packs with the battery management systems, any electrical connections or software. There's fierce global competition here as new technology comes in, and we've already heard about a lot of the new improvements in energy density and driving range, reductions in weight and cost. And this is, as I said, fierce global competition between the battery manufacturers to keep this part of the value chain with them. But we also see OEMs moving into this realm to customize their battery cells, particularly when they're sharing battery manufacturers. Also, control, we know they like that as well. There's money there. There's money perhaps that they can earn through the IRA. And again, perhaps, as we've heard earlier, this is a step maybe they will continue to do, or maybe not. It depends how it shakes out, I think, in the future. Electric vehicle manufacturing, there is money as well in the IRA for retooling, $2 billion in loans available for retooling manufacturing facilities. I believe that's workforce, trying to keep the workforce where it is, and using the facilities that already exist. So we see a lot of retooling and revamping existing manufacturing facilities to develop EVs, to manufacture EVs. Battery in use and second use, we didn't really focus on that, and I apologize, there's a lot of interest in that, but that's the life cycle of the vehicle and the battery. There is a lot of interest in recycling the battery for a number of reasons. One is because of the waste and the resources available there. The large recycling companies are using the spent batteries, which we've already discussed. There aren't that many. There's not a great volume of that right now. But they're also using the scrap from the cell manufacturing. And as so many of these cell manufacturing companies come online, they create a lot more scrap or waste at the beginning of their production than when they get more efficient. So for a few years, maybe there'll be a little more volume there. They're also competing to purchase raw materials. They're competing with other elements of the value chain for these raw materials to be able to produce, to refine the materials and produce materials that can be used again to source battery cells. So that's what we're seeing from the big companies. So about 95% of some of the critical minerals can be recycled from this waste and spent batteries. So there is a market for this supply. For lithium, it's a lower amount. It's about 80% of the lithium that can be recovered. Argonne National Lab did verify that the cathode material, Redwood Materials, which is one of the big recycling companies, they did verify that their cathode materials created from recycled materials perform as well, or in some cases maybe have some better qualities than cathode materials produced from raw materials. So this is an important potential source, I say potential source of supply going forward. And again, Redwood Materials believes that they, in their 2 facilities, will be able to produce enough cathode and anode materials to supply 1 million EVs in 2025 and 5 million in 2030. So it's still, it's a significant amount of supply, considering there are several of these companies out there working on this. So just again, looking at the circular value chain, each step fuels the next step. So timing is huge, risk, uncertainty. There's just so many steps along the way that we could see bottlenecks. We could see substitutions, we could see technology changes at every level, including the raw material level. So this is just a whole moving target. It's not as neat as it looks. Okay. I've been looking at a lot of spreadsheets. I wanted to see how is this really coming to life. So I put it together using that circular value chain. What I've done here is I've taken contracts, a lot of them are recent, binding contracts, agreements, commitments that Tesla has here. As you can see, this is the same circular value chain I was looking at before, top heavy with raw material manufacturers, agreements that they have. Okay, The blue are companies that are supplying Tesla here with supply from North America. The orange are companies that have supply from our trading partners. And the yellow are companies that have supply from both North America and trading partners. Albemarle, for example, has a lithium mine in Nevada, and they also have lithium brine production in South America. So you can see Tesla, you'll notice, has a very different strategy. When I show the other manufacturers, they are vertically integrated, very much so. This may look like a BYD, I would imagine. They are involved in every step of the supply chain except for raw material manufacturing, which they have talked about. So don't be surprised if that happens. Many of their lithium contracts are new or expanded to supply the refinery that is under construction in Texas. They're the first manufacturer to have their own lithium refinery here in North America. They'll be producing their own cathode material. They have a volume that they're trying to satisfy. And that's why I believe they're, for cost and volume, they're getting involved at every step. In cell manufacturing as well, and recycling. They've been working on recycling since the beginning of their production in Sparks, Nevada. Another note here, they have each of the manufacturers I'll show has a strong relationship with a battery manufacturer. Tesla's is Panasonic, and Panasonic as well has gone out and made a lot of the same type of supply contracts as well to fulfill Tesla's needs. Again, vertical integration, very different from any other North American company. Here's General Motors. You'll notice there's a lot of blue in this picture. General Motors has made a strategy of trying to source as much of their materials as they can from North America. So they've also paid a premium for this. They've made investments larger than anyone else in sourcing raw materials from North America. They have a $650 million sourcing agreement with Livent America for lithium. This is for a lithium facility that could take years before it goes into production. $650 million. Again, they've invested to receive this supply when it comes online. So they're also making these investments to advance the production of these materials and to lock them in, like perhaps 100% for some of the agreements will go to GM for the first few years. They have another one with Livent for 190 million. Let's see. So they do have, again, a strong relationship with Ultium Cells. We heard about that from Mr. Shin with LG. Ultium Cells has a JV with POSCO Chemical for a cathode facility, $1 billion cathode facility going into Quebec. So Ford does this as well. They also have a JV for a cathode facility to lock in their supply and be able to source their battery needs. So, General Motors has 3 different recycling relationships. Remember, Tesla was doing their own, and these are, they're all a little different. Li-Cycle is co-located at one of the Ultium facilities. So they'll have those resources to them as soon as possible. Ford has a similar type relationship-based sourcing as General Motors, a little bit similar. They do have fewer relationships. It doesn't mean they'll receive fewer supply though. They have, see, I'm not sure I said, General Motors has last year announced that they had locked in the supply binding agreements to source their 1 million EVs by 2025. Ford has announced that they have about 90% of their supply locked in for their 2 million EV production strategy by 2026. So. And again, they have a cathode JV, and again in Quebec. And they have a strong relationship with SK for their 3 facilities. They'll be the 3 battery facilities they'll be building. They just received the largest loan from DOE to complete these facilities, $9.2 million, I believe, in loans to, that was just like 2 weeks ago, to complete the battery facilities with SK. And they have a licensing technology agreement with CATL. That's a $3.5 million plant in Michigan. They have a strong relationship in recycling with Redwood Materials. It'll also be supplying cathode and anode materials for them. For me, this was fascinating to put together the spreadsheets and see how these relationships were shaking out, where the resources were coming from, and the timeline too, which I don't have on here. It got a little messy. The amount of supply and the timeline. Again, it's overwhelming how many of these relationships are new and expanding. We'll talk about that here. So battery cell manufacturing, this is a big part of the picture. Just looking quickly here at a very familiar automotive corridor, the I-75 corridor is now being named, in many cases, the battery belt. Much of the investment we're seeing through the battery manufacturers is located here along the battery belt, specifically in the southern states. Georgia has the most, and primarily South Korea in there. The batteries are heavy, they're volatile, and they're locating for the most part near the EV manufacturing. As I said, a lot of the EV manufacturers are retooling their facilities, or they're locating in these manufacturing, automotive manufacturing friendly states, let's just say. This is another look at the same type of map. I've added the different facilities here. There's 28 of them. These are 28 operating, under construction or announced facilities that will go online by 2026. And I've only included the big ones, the ones that have agreements with OEMs. That's how I weeded these out. What I notice here when I look at this is the concentration of the projects. I notice also the relationships, the concentration of relationships. They're partnerships or joint ventures. That's what we're seeing. That's to share the risk, and that's to share the investment, and to lock in the supply for the manufacturers. Let's see. $71 billion of investment here, 82 million from this planned in the future, and 773 gigawatts of capacity. It's a little different from some of the other ones you'll see out there, but again, this is the one, these are the projects that have manufacturing contracts. I took 2 months away from this, and there were 9 new projects or expanded projects in 2 months in the spring. So out of 28, It's unbelievable. Again, I haven't updated it in a few weeks. I apologize. It's completely outdated. It's moving so fast. So just some final thoughts. The fierce global competition, it will continue within the companies here and as well with China. I think politics at every level, on the local level, we're seeing it affected some of the new projects. Maybe communities aren't as welcoming as you would imagine for new jobs. Geopolitics as well will influence the transition. Our relationship with China going forward, especially in the near term for sourcing and as well with our allies. Bruce and I were just at an international conference in Europe. A lot of talk about the competition, about what's the word I'm talking about? Protectionism. A lot of the Europeans seeing our policy as very protectionist. And we've seen a lot of countries protecting their resources, some of our trading partners and allies, but as well trying to create their own domestic industry. So that'll affect the timing and the sourcing of our supplies going forward. We can't do this without our trading partners and allies. We need them to source our industry. The industrial policy momentum we've discussed is tipping the scale and reshoring and locating manufacturing here. Timing of the circular value chain, it's critical. As I said, there's risk, uncertainty, there will be bottlenecks, there will be solutions. We don't even know what they are right now, some of them. Relationships, as I showed with the battery manufacturers, create opportunities. They share risk and cost. Technology could change the direction of the value chain. That's at every step of the value chain. We're looking at huge technology advances. And I didn't even go into how the manufacturers in the industry, the government as well, is investing in technology and hoping for these advances to help us propel our domestic industry. As always with auto, there will be winners and losers. There will be consolidation. That's no surprise. I showed how the domestic value chain is developing, but we do recognize that this is a long-term proposition. It may look very different from my nice little picture, and it will take years. It will require patience. It will require paying a premium for operating here in North America. And I showed that with General Motors and their enormous investments to have a domestic supply. So thank you, and let's eat, right? No more questions, right? Okay.
Very good, Kara. You got all this stuff going. It was a very good insight into what your work has been doing, what you've been doing for the last 3 years studying this.
It was a nice wrap up of everything else.
Question for you. Tesla has a gigafactory in China. Is Tesla's supply chain for US gigafactories North American based or also sourcing significantly from China?
Yes. Tesla has an enormous supply chain, right? They're an EV only company, and they have been making these contracts directly with raw material manufacturers around the world and other suppliers around the world for years. So that's originally what I was looking at. But what's happened with the IRA is, and other, as I said, as companies jump online and say, you know, we are going to manufacture here, or we're already manufacturing here, we're going to move into auto, you know, and these are companies like, for example, big chemical companies that are recognizable and have a volume they can source. So as they jump into the value chain here, develop operations that could source a Tesla, for example, here in North America, we're seeing that happen. I only included the agreements that I saw that would supply their North American production. So that would be compliant for the IRA. So what Tesla has done too, and this is my last point, they have gone back recently in the past several months too, and renegotiated some of their supply contracts where they were receiving materials from a company that has several different sources, countries of sourcing, and renegotiated a contract to have the sourcing that would be compliant here, perhaps with the same company. So yeah, that's what I tried to show was the North American sourcing. And that is where the excitement, the momentum, the investment has been.
Kara, did you sum up, I may have missed this in your presentation. Did you sum up all the numbers of investments and the gigawatt hours that has been invested so far from your research?
I did. I have it right here. The battery cell manufacturing, what I totaled online by 2026 with 28 projects. That one map I have. $71 billion of investment with 82 billion in the future. Some of the companies had a date on in the future and some of them didn't. Those were plants, thinking like a Stellantis plant in Indiana that had a, we're going to produce this amount, and in the future, this same plant could produce this amount with a certain investment. So that would be included in the $82 billion in the future. And that was 773 gigawatt hours of capacity is what I saw. And again, that was updated in June. So sure it's updated.
Thank you. You've also focused on recycling in your research. What investments do you see in the U.S. and what relationships do you see with the manufacturers?
And also, I want to welcome anyone else that has comments on this. I'm looking at public material, and y'all have some insight to share. So please join in. As far as recycling, there's been quite a bit of interest in this from what we've seen, and investment. Ford invested in $50 million in redwood materials in 2021. And I remember looking that up, wondering, what that was going to turn into, that relationship, because that was Ford saying, here's $50 million, let's start talking about what kind of relationship we can have. And, we want you to advance your manufacturing, your operations. And so those type of relationships began forming. 2021 seems that's history looking at this. So we've seen that relationship develop with Ford. General Motors has 3 different recycling companies that they've partnered with different types of relationships. Li-Cycle is, as I said, located on site at their Ohio Ultium facility to be able to recycle scrap and supply them with, in the future, hopefully cathode anode materials. Again, these are developing relationships, under construction type things. Something we've also seen is Panasonic's relationship with Redwood Materials. Again, they have a contract with Redwood Materials to produce anode copper foil exclusively 100% for Tesla. So, and that's not a contract with Tesla, that's through Panasonic, but that is being produced actually, I believe, mostly from raw materials because they don't have enough of the volume in the scrap and the spent batteries to do that. But that is, I could be wrong, but I believe they're the only ones producing that valuable component here at this time in North America. And that goes again to Tesla. So they're looking at these recycling companies as a future source of supply. And that anode copper foil from Redwood Materials is coming online as we speak, I believe. Soon.
Let's
Anyone
see.
else?
Yeah.
Do y'all have any comments?
You've, we still have some questions for you, don't worry.
Let's see.
For recycling, I think we've talked a little bit about this. I think we asked Jing-Wan about it, about what happens if the technology changes. We could actually ask that question. We should have maybe asked the question to him about how manufacturing changes when the technology, when the material changes. Isaac, do you have any insight on that you want to share about how it might change, if how the manufacturing might change if the technology changes? Do you have any insight on that? Yeah, come on up.
Yeah, so from the perspective of in the context of recycling, it's one of the big challenges. I think that's why the question and comments that were coming earlier about how long is that lag period between when the vehicle is sold and when you can actually realistically capture it and want to recycle it. Along that timeline, and depending on how long that time actually is, it's going to impact how relevant those materials still are. So I think there's still going to be a pretty large production base and demand for nickel-based chemistry. So I think it's fairly safe to say that lithium, nickel, cobalt will still be valuable. But in terms of the role that recycling can play, again, the recycling recovery rates, lithium's like in the 70s, nickel and cobalt can be much higher, but it doesn't solve all your problems, especially with that delay. And so, yes, I think it has a role to play, but it's not going to backfill for NCM. And then as chemistries change, it's not going to be able to be a perfect substitute, even if you could get 100% recovery rates, which you can't. And then in terms of manufacturing technologies, I think there's a lot of new developments that are underway, whether it's pre-lithiation, faster coating speeds, dry coating gets talked about a lot about. All these have a potential to reduce the CapEx requirements in manufacturing and bring down the costs. But a lot of those changes end up being a little more on the incremental side when you really do the math on it, just because there's other tweaks that you have to make in the manufacturing process, and so much of the cost structure of a battery is still material based. So even if you do invent or come out with and properly industrialize one of these newer production technologies, you still need to get the refinement of the process in place. Use additional CapEx that oftentimes goes unaccounted for in the plans or in the initial claims, and then simultaneously the impact on your cost structure is beneficial. It can provide a competitive advantage, but it's not going to bring down the cost of a battery in terms of, an order of magnitude that would allow you to stuff that many more batteries into a car economically.
Very good, thank you. I thought that the statement, Kara, about the Redwood Materials actually bringing in virgin material for the company, which is a recycling company going, we don't have enough to recycle. We're actually going to get into this other business, be able to do this as well. That's a fascinating piece.
And the bigger recycling companies like Redwood Materials, they're also buying recycled material from other recyclers, like black mass from other recyclers that aren't going to specialize, in the refining and remanufacturing of this. So they're out there buying from everyone. So I'm interested to see. They seem some of the companies out there, some of the examples we're seeing around the supply chain seem to be more flexible than others going forward. So they're the ones that are interesting to watch.
One of the comments from the audience was that there many materials for vehicle electrification are 100% imported from outside the US, how can we maintain momentum if protectionism kicks in? I think it probably has something to do with the trade agreements. So that if you actually have trade agreements with other companies, other countries, you will be able to get sources from them legitimately and still be able to get the credits that the government's offering. So that's one way of dealing with it in terms of in getting the credits. And because we do have there's only a limited number of countries that we don't have these kind of agreements with. So I think that would be the advantage for that. Last question for you then. Do you think the OEMs are taking too many risks in developing the battery value chain, where the technology may change in 10 years?
I don't have a clear answer for that. I do know that they have invested heavily in new technologies in all sorts of at different levels of the value chain, all sorts of technology. And that's my answer. I guess that some companies and some of these investments tend to be more flexible than others. So I don't know. We'll see.
So some of the agreements.
I don't have. Does anybody have?
Some of the agreements are more flexible, right? So that you can actually get out of them if things are not going as planned. Yeah.
Anybody comments about
Isaac, do you want to get the last word in on this? Go on. Are the OEMs taking too many risks?
I don't know, it implies a judgment to say that they're taking too many risks.
We don't have to name
There's
names.
different trade-offs involved. One of the things to remember is that right now there's a huge opportunity to get significant subsidies, whether it's through low interest government loans or local subsidies or DOE grants, et cetera, to help fund the investment. It's also part of a strategic decision to build up those capabilities to de-risk their value chain in some ways, and they have to take on other risks. So right now there's an opportune moment for OEMs to be able to subsidize some of this investment. Once that CapEx is in the ground, there's also the potential to repurpose some of that. So there is some flexibility. You can leverage some of the machines, you can repurpose equipment if you really need it to. And the other thing is every OEM and every supplier is they're operating on certain return payback profiles, and they're expecting to recover their investment ideally within that decade. So if you're talking about evolutions of battery chemistries beyond that decade time frame, I think they'd be okay with that, even if they couldn't recover some of that CapEx that's already in the ground. But it's so heavily subsidized that I think it ends up working. Like I said before, I think the pendulum will swing. So right now we're seeing a lot of OEMs intending to bring more of that capability in-house, whether it's production and or R&D. But we'll probably see that those intents start to walk back a little bit, perhaps in the next 5 or so years.
Very good. Very good. Thank you, Isaac. And thank you, Kara. Very good presentations. I think that's going to be it for today. First of all, as part of the closing, I want to again thank our affiliates. We couldn't do it without you. We appreciate the support that we get from our affiliates to be able to fund our research and also help pay for the conferences. Our next conference is September 13th. The future of automotive IT, artificial intelligence in the automotive industry, in the vehicle, inside the vehicle, and inside the company. So that's one of our goals of talking about that. And I think we'll have an interesting discussion of things that may happen in the future, as opposed to certain certainties about what's going to happen. Reminder to please, if you haven't, please join us on LinkedIn to connect with us and follow us. We'll be posting some of the slides from today's conference with some information about those, some analysis. One of the things that we offer for the conferences is a Meet the Speakers program. So if you have an interest in meeting one of the speakers, feel free to reach out to me and we can make a connection to help you to meet with them. And presentations and the video of the conference will be on the website by this weekend. So you'll be able to have that available to you. I think that's it for today. I want to thank all our speakers. Thanks our audience here in Ann Arbor at the University of Michigan, and also our coterie of online folks who are following us. Thanks again for participating to our speakers, and thanks for our attendees for participating in the conference. We'll see you next time.